Today's lesson is solving problems from data on line plots. It's very important when you're dealing with line plots is to read the problem and also read the headers of the line plot so you know all the data that's being used. Let's take a look at this problem. The plot below shows the length of each of the 7 bulletin boards hanging on the 5th grade hallway. If the 3 longest bulletin boards were placed side by side, what would be the total distance? You can see the line plot down below. It goes from 1 through 4, and it's split up in halves. Each dot represents a different bulletin board, one of the 7. Now let's start by identifying the important information needed to solve this problem. Well, if we read the problem again, it says if the 3 longest bulletin boards were placed side by side, what would be the total distance? So you can see by the rectangles that's the important information we need. Now we need to develop a plan to solve this problem. Well, since it's talking about the 3 longest bulletin boards, we know we can make just a equation saying L1, L2, and L3 being the 3 longest bulletin boards. And it says place side by side, so we know we're going to have to add them up to find the total distance. Now that we have a plan to solve the problem, we need to identify the information from the line plot needed to solve it. As you can see, since the line plot goes from 1 through 4, and it's indicating how long in meters the bulletin boards are, the 3 dots all the way to the right are going to indicate the 3 longest bulletin boards. So we can say that L1 would be equal to 4, L2 would be equal to 3.5, and L3 would also be equal to 3.5. Now we can solve the equation. Let's go ahead and input the numerical values. So L1 became 4, L2 became 3.5, and L3 became 3.5. When we add them up, we always want to start adding from left to right. So 4 plus 3.5 would have gave us 7.5. Now we have to add 7.5 and 3.5, and we end up with 10 and 2 halves, which become 11. So we can say that the total length of the 3 bulletin boards placed together was 11 meters. Let's look at another one. The plot below shows the length of each of the 15 strings used in the pendulum experiment. How much longer is the longest string than the length of the 3 smallest strings combined? And in this one, the graph is measurements are rounded to the nearest 1/4 inch. Now, if it didn't tell you that, you could look and see how many divisions were between each inch. And on this one, you can see it's segmented into 4, so we know each one would be 1/4. Well, let's start again by identifying the important information needed to solve the problem. And we do that by going back and rereading the problem. How much longer is the longest string than the length of the 3 smallest strings? And the key word here is combined. Now we have the important information. Now we can determine a plan to solve. Well, we can tell by the problem that we know we have to have the longest string, and it wants to know how much longer it is than the 3 combined, so we know we're going to have to subtract to find how much longer it is. We're going to have to combine the 3 smallest strings to find out what the difference is. Now let's identify that information needed from the line plot. Start off by looking at the longest string, and once again we can see that the plot is from length in inches, so all the way to the right we have this one, which is 12 3/4, so that would be our longest string. Now we need to identify the three smaller strings. First one being all the way to the left, the smallest is actually 3. The next smallest is 4 1/4, and the third one is 4 2/4. You notice I didn't go to 1/2, because since I'm having to add these, I'm going to go ahead and keep them in quarters. That way they're already in common denominators. Makes it a lot easier. Now we're going to have to simplify it. Solve the expression, we got to simplify it, which means just basically add or subtract. Now you always, like I've been telling you, start from left to right, but in this case where you have parentheses, you would start within the parentheses first. And we're going to go from left to right within the parentheses. So we have 3 plus 4 1/4, and that would give us 7 1/4. Now we have to add the remaining 4 2/4, which is going to give us 11 3/4. Now that we have combined all the small strings, now we can see what the difference is, or how much longer the longest string is, by subtracting it from the combined length of the three smallest strings. So we have 11 3/4 minus, 12 3/4 minus 11 3/4, which gives us 1 inch. So we can say that the longest string is 1 inch longer than the combined length of the three smallest strings. Alright, now let's look at a different style problem. In this plot below shows the amount of orange juice Snow White gave each of the 7 dwarves. If Snow White redistributed the orange juice so that each dwarf received an equal volume of juice, how much juice would each dwarf receive? Now in this one you can see it's saying that all of measurements are rounded to the nearest quarter fluid ounce. And you can tell that by looking down. You can see that in each ounce is divided into 4 equal sections. And you can see the title says orange juice received by each dwarf. Well, let's start again by identifying the important information. Now in this problem it says Snow White redistributed. Now we have to determine what that word means. If we go back to the root word, to distribute means to give out. And the prefix re means to do again. So she, once again, is going to give the orange juice out to the dwarves. And we want to make sure, she wants to make sure each dwarf receives the equal amount of juice. Now, we understand what the problem is, we need to develop a plan. Well, if you visualize this, you'd think Snow White poured juice into 7 different glasses. Then she noticed that they were of different values. We had 4 of them down here, with 5 of them. They were 10.5 inches, 10.5 fluid ounces. And we had 2 of them that were 12 1/4. So she poured all the glasses back into a pitcher. So in all actuality, she had to add all the juices that she'd given the dwarves back together, and then she had to divide that number of fluid ounces by the number of dwarves again to get an equal amount for each dwarf. So let's start off by adding all the juices together. Now you can see here we had 5 10 2/4. So when we add those up, we get 50 10/4, which we know that in proper fraction can be changed to 2 2/4, so our total would be 52 2/4. Now we have to add the last 2, which are 12 1/4, which gives us 24 2/4. Now that we have both our partial sums, we can add them together, and we end up with 76 4/4, which gives us a total of 77 fluid ounces. Now that we know how much total fluid ounces we have, we know we can divide that. And there are 7 dwarves, so we have 77 ounces divided by 7 dwarves, and each dwarf will now get 11 ounces. Our last problem we're going to work Says the line plot below shows the volume of each of the 11 river water samples collected by an ecologist. The volume of the largest sample has blank times as much water as the volume of the smallest sample. In this one you can see the measurements are rounded to the nearest 1/8 gallon. Once again, let's start by identifying the important information. So the volume of the largest sample, it has blank times as much volume as the smallest sample. Now we need to develop a problem, a plan to solve. Well, what we can say is that since the largest sample has blank times as much water, we know the small sample times some value has to equal the largest sample. Now that we have our plan, let's identify the information needed from the line plot. First, we need the largest sample. In this case, we have two samples that are equal, but we only need one of them, and so we know that is 7/8 gallons. Now we have to identify the smallest sample. Once again, we have two, but we only need one of them, and we know the smallest sample is 1/8 of a gallon. Now, our plan, we can solve the equation. So let's import our data for our variables, and we have the small sample, which is 1/8 times some value equals 7/8. Well, we know that when we multiply fractions, all we do is multiply the numerator to the other numerator to get our product's numerator. So in this case, we have 1 times something equals 7. So we know 1 times 7 equals 7. Now our denominators, we know we multiply our denominator times our bottom denominator to get our product's denominator. So we know 8 times something equals 8. Well, 8 times 1 equals 8. So now we see that 1/8 times 7 over 1, or 7/1, which is equal to 7, equals 7/8. So we know that the largest sample is 7 times as much water as the volume of the smallest sample.